Thank you for that, Erica. Nice music. Okay, if you can please take your seats, and we'll start the afternoon session. And we'll start with a new session called Global Sea and Sea Ice Surface Temperatures, Climate Data Records, Trends and Indicators, Trends, Indicators and Definitions. And I think the first presentation is a keynote presentation from Karina von Schukmann and from Mercator Ocean International. And I hope Karina is online. And
yes, I am.
Perfect. Karina, you have 30 minutes. So thank you.
Thank you very much. And I hope the background noise will be not too disturbing. So thank you very much for this opportunity to bring in some aspects on the current activity at the Science and Policy interface, but also with respect to reporting, which is based on ocean indicators. So I would like to start with a very general introduction. I mean, you are all aware of this and you're all experts, but I would like to take the opportunity to put it together as a type of introduction of why I think it would be important to create a specific dialogue around the ocean indicators. So I start with the big message of that all people on Earth rely on the ocean, either directly or indirectly, and that they nearly 28% of the population is living in to the coast, and this has been highlighted in the SROC, IPCC SROC. So, and another message is also to highlight again the importance of the ocean, which is vital for sustaining life, for regulating Earth's climate, and providing multitude of services and resources, important for the livelihood, but also and source supporting bodies for the sustainable development, resilience, well-being, and cultural identity, and also for the economy aspects. So, but the ocean is highly under pressure, so we can call it a triple planetary crisis or something else. So there are the major drivers of change are climate change, pollution, and the biodiversity loss. So just quickly around on the different risks which have been assessed in R6 and working group 2 with respect to climate change and different ecosystem types like warm water corals, kelp forests, and seagrass meadows, pelagic, rock shore, and salt marshes, where you can see the gray line, which is the 1.5 level, and the colors show you the different levels of risk depending on the different scenarios. So I'm sorry, I should have added. So these are scenarios, the 8 and 4.7 and so on. So so which is really with a big message, the further we go, the higher the risks will be for all types of ecosystems in the ocean. Another aspect from the ocean is together with the ice shelves, deep body or the deep ocean, which is ensuring the long-term climate inertia. So, and meaning that there are some changes which have reached in the deep ocean, and also for ice shelf stability, which are changes which are reversible for centuries to millennia. Then a quick check on the pollution as done in IPBES is published in 2019. Here just an aspect on the water quality, where you have here an estimate on the river plastics waste into the ocean, and other aspects include untreated urban sewage, industrial agricultural runoff, erosion, airborne pollution, salinization, oil spills, dumping of substances. And so there was, for example, this messages in IPBES that it is estimated over 80% of urban industrial wastewater is released to freshwater systems without adequate treatment. And then there's also this aspect on plastic pollution in the ocean, which has increased tenfold, which is also here assessed in the IPBES in 2019. Then to draw quickly on the biodiversity loss, these are just some examples of global declines in nature, including the ocean, emphasizing declines in biodiversity that have been and are being caused by direct and indirect drivers of change. So you have here, for example, the biomass and species abundance, ecological communities, etc., which also incorporate the ocean. And with respect to the extinction and the trends, so there's a specific data set incorporated here with respect to the warm water corals, which have shown immediate decrease in a risk of extinction. So more than ever, there's an urgent need to monitor and report on the state, variability, and the change of the ocean, as the ocean is facing mounting pressures from the triple planetary crisis and over-exploitation, to add another, and threatening both marine ecosystems and human well-beings. So another positive message is that the ocean is gaining more and more a prominent role in the global diplomacy, and which in turn also reflects its importance in the Earth system. So this is just a schematic of the ocean climate nexus for the different types, with the science and data and services, really the backbone of supporting convention, sustainable development agreements and treaties and governance, with the different tools like negotiation processes such as the Ocean Climate Dialogue, financial instruments, summits, fora, and conferences, and at the bottom level, scientific assessments, which are highly based on ocean indicators and climate indicators. So there's just some listing here without being a comprehensive approach on the ongoing types at the international scale. But just to show that is more and more a need to provide evidence-based information as a business knowledge transfer for informed decision-making and support of all those different activities. So why are indicators hence important? So the ocean science supported by ocean data disseminated through national, international ocean weather and climate services. They provide critical input to operation forecasts and foundation for evidence-based decision-making. So this is just a schematic of a so-called added value chain, but there are different ways of showing this different levels with respect to coming up to the concept of ocean indicators, showing here that they are really sitting at the edge, important to ensure or facilitate, not ensure, to facilitate knowledge transfer from the environmental pillar of sustainable development up to the societal and economic pillar. And in order to support this transfer and also in support again of informed decision making. Of course, the concept of indicators is not new. So there are also already many implementations done. So there are some examples here. Of course, IPCC and IPBES are using indicators as shown. The CBD has a specific development around indicators, so-called Biodiversity Indicator Partnership. The World Ocean Assessment, of course, using indicator. We have the concept of the WMO on the global climate indicators, from which the majority are ocean-related indicators. And of course, a SDG framework, which is with its many targets, another important aspect of how the use of indicators plays a significant role in this interface. But these in existing environmental indicators using these various initiatives, they vary in terms of methodology and the information required, the disciplines, and so also the level of rigor involved in the different processes. So to be really effective, it's important to have a reliable and comparable methodologies which are frequently updated, not in terms of only of the data to be close to real time, but also with respect to evolving science or information and methodologies. So I give you an example, another example why it is important. So, and why we should maybe care as a scientific community. So we have one very prominent example of indicator, which made it to become a political target, driving international negotiations. So this is the current level of 1.5 degree from the global mean temperature aspect. For us as experts, it is something which we think, bah, it's easy, we average together and then we provide these values. But there is no agreement on how we are doing this. So depending on which reporting we use, you have different estimates, different values. So it's very confusing, for example, at policy levels. So we understand that, okay, we have used 10 years running average, or we have used 5 years running averages, and we have different products, we have used different periods and so on, but this is just already too complicated to transfer at the science and policy interface. So there's also a lot of efforts, and there's also a paper ongoing at a GHRSST level with respect to reconciling methodologies and find a community reply for consistent reporting on when we cross 1.5. Then also we can see that the indicators are critical drivers for reaching a wide audience. For example, that is the media uptake. So I think more or less everybody of you had been somehow involved or is aware of the different media uptake with respect to what had happened in 2023 and 24 with respect to the warm surface temperatures, just an example. So it had a high visibility in international media. And this high media uptake also is tightly linked to engagement and research. So there are new papers coming up at high-level journals, also operational services. So there have been much increased engagement in the messaging on these indicators. So I choose here specifically, of course, the example on the sea surface temperature and also at international level. And there are also, of course, various efforts to provide new digital tools at service level elements, such as, for example, in the Copernicus components or in other tools, so which provide this data and use different types of data in order to develop and inform the greater, wider public and policy. So, but it's very different messaging when it comes to the technical quantifications. Again, if we read this messaging, we understand and we can interpret, but it's just highlighted here in bold the different values for degrees Celsius. So for a non-expert or even a politician, this is very confusing. So we have a 0.6, 0.9, then we have 1.29, and I know we know it's from the different aspects how you calculate this, but just to have the numbers is highly confusing. And also these differences occur due to difference in reporting priorities and methods, different in the periods and in the products used. And again, the discrepancies are really explainable at expert level, but it's really difficult to follow at a non-expert level. And this can harm really the trust building, environmental and science-driven knowledge transfer. So we really need to move forwards. We need to move towards consistent and agreed indicator-based reporting approach to ensure united voice for the ocean. So we started some activities, but it's not the full reply. So it's just the starting of a dialogue. So we have built, also if you look into literature on the definition what an indicator is, and also if you discuss within the community and outside the community on the understanding of what an indicator is, there's a wide diversity. And also in implementations as just shown before. So there had been an initiative at the GHRSST level across the 3 panels of GHRSST, ocean and climate, a physical panel, biogeochemistry panel, and biology and ecosystem panel, with building on the main definitions for indicators which exist, and with the experts from those 3 panels to cross these disciplines, and also with a specialist in sustainability, international environmental diplomacy. We have agreed on the following definition for science-based ocean indicators. So, you cannot read everything because I have some technical issues, but I'll leave it up to read you this definition, and of course the slides will be shared. And we have discussed a lot on this definition, and really every word is well discussed and chosen for a reason. And we have just submitted a paper, then put aside here, where we also explain why we have chosen these different words and what is the rationale behind. Then we have also developed some ocean criteria. So we have agreed to bring forward 6 different ocean criteria to understand what an indicator could be and how we can evaluate. That is the specific proposed indicator on discussion. So we have verified, significant, scalable, justified, measurable, and accessible. And we have also proposed a type of expert assessment so that if there's a discussion, there could be then an implementation or let's say an assessment on the different levels of a given indicator, such that it is still at a concept level, that it's still a pilot, or it's very mature methodology already. So then we have also proposed 9 pilot indicators where we apply also this assessment and the in order to talk about the criteria, etc. And also to come up to say whether this specific indicator is a concept, a pilot, or a major state. We have 3 indicators with these 9 for each of the panels to cover all the different dimensions. Those went under GOOS, and in order to further advance on those indicators and start the dialogues as such for many directions, but also the dialogue as such, I would like to start with this community today. So this is my last slide, just to come with the synthesis. So there's a unique opportunity to reconcile our efforts for a united voice for the ocean. And so no more than ever. So I'd like to repeat, there is an urgent need to monitor and report on the state, variability, and change of the ocean as it faces mounting pressures from the triple planetary crisis and overexploitation, threatening both marine ecosystems and human well-beings. But the methods and data products advance, inconsistencies in indicator-based reporting are becoming more apparent, and it's challenging the continuity and comparability of regular assessments. I have not put in the comparison, but I've shown this for the global scale. But if you even go at regional scale, it's getting even more difficult because, for example, we define an area such Europe, for example, we also have to agree what this area is because apart from the other aspects I just mentioned. So what can we do? Here's just some first suggestions to start a dialogue. So at expert level, it is maybe you need to face expert fatigue for the growing demand of evidence-based indicators and also in operational manner and also with respect to uncertainties. So we need to further evaluate amongst us and emphasize the imminent importance for the provision of this timely information and also information which is based and built on best available science, which is also evolving. So we need to agree also on the processes to ensure that these innovations will also be reflected on those indicators and to ensure robust uncertainty frameworks. Also need to drive momentum to build on scientific consensus and joint efforts for coherent implementation. And for this, we need to join forces to ensure trust building at the science and policy interface. And the service level, I think there's a need to face a growing inconsistency in indicator-based digital services and reporting for the ocean. So there's an opportunity to build an alliance for a united voice for the ocean, need to build on consistent approaches, and also to explore possibilities for cross-coordination and agreements to enable a coherent view on the indicators. Well, thank you very much, and very happy to start some discussions.
Thank you very much, Karina. I think the way we structured is that we'll take the question. We'll first have 3 presentations, and then we'll take questions in the end. I hope you stick around for that.
No, I'm sorry, I will be not available, but I'm happy to then engage online via email.
Okay.
Thank you very much.
No, Karina. In that case, I think we'll just spend 5 minutes on the questions to you, because I think it's important we get some interactions here. Yeah. So, are there any questions, comments from the audience? Chris.
Hello, Karina. Chris Merchant here. You mentioned the ongoing effort to address how the surface temperature indicator is going to be constructed. So at present, you're not aware of any equivalent thing addressing ocean warming, which was one of the 3 physical observations. Is that what you're saying? There is no such equivalent of effort to Peter Thorne's effort on the surface temperature?
I think that for some there are. So, I mean, we have the Global Carbon Project, we have the Earth Heat Inventory. So that's, for example, for your question with respect to the ocean heat content. But for sea level, for example, we don't have anything. For the sea surface temperature, we don't have really an agreement or a way. And I think it's also going further. So there's one aspect which you mentioned, and that's a very critical one, and that's why I also start this dialogue also at expert level. What can we do as a community to make this happen, to find this consensus? And these are these examples of where the community is starting to put their forces together. but it's not done for all type of indicators. Acidification, nothing. And sea level is a big issue as well.
Thank you, Chris. I have a question, Karina. I don't see anyone else here. So Karina, you have a collection here, the largest collection of sort of international experts on sea surface temperature in terms of producers and in terms of the science. So I think it's really interesting. I mean, is within GHRSST, is there anything? I mean, what can we do in order to help with these things and to facilitate this the sort of derivation of robust indicators? Is there anything you're well, both in terms of products, but also in terms of initiatives that you're lacking on from the sea surface temperature community?
Yeah, thank you very much for this question. So I think for the sea surface